L'eau est une ressource essentielle qui est menacée par les impacts du changement climatique. Le dégel rapide du pergélisol dans la région du Dehcho, dans le territoire nord-ouest, est en train de transformer la façon dont l'eau est conservée dans les terres, comment les plantes s'en servent et dans quelle mesure cette eau a une incidence sur les processus pédologiques.
Permafrost thaw changes how water moves on the landscape. This affects the flow and quality of water in creeks, rivers, and lakes. Permafrost thaw thus have impacts on both ecosystems and humans, and at both local to global scales.
Je m'appelle Oliver Sonnendag, je suis professeur agrégé et titulaire de la chaire de recherche du Canada au département de géographie de l'Université de Montréal.
And my name is David Olefelt. I'm an associate professor in the Department of Renewable Resources at the University of Alberta in Edmonton. Together, Oliver and I have led a project funded by the Northwest Territories and the Cumulative Impacts Monitoring Program between 2018 and 2021. This video, we will summarize the project and the team members will present the main findings.
Le but principal du projet était de faire ressortir les conséquences du dégel de pergélisol sur les eaux dans la région du Dehcho, le paysage de tourbe boréale qui se dégèle à un rythme accéléré. Les tourbières sont des sols organiques très denses, composés de matières végétales mortes qui ont été accumulées sur une période de plusieurs milliers d'années. La région du Dehcho, qui est située dans les plaines de la taïga, est l'une des plus importantes régions de tourbières au monde.
Much of the peatlands in the Dehcho region are perennially frozen. A frozen core slightly elevates the ground, making it relatively dry and gaining enough stability so that spruce trees can grow. With climate change, we are seeing permafrost thaw. And this can happen either by a gradual deepening of the thawed layer near the surface, or by a complete thaw, which often then leads to a land surface collapse. Land surface collapse causes trees to die, the ground to become much wetter, and become dominated by sedges and mosses.
Par conséquent, le dégel du pergélisol transformera la façon dont les tourbières emmagasinent et transportent l'eau et la façon dont les plantes consomment l'eau et la rejettent dans l'atmosphère par le processus de l'évapotranspiration. Le caractère humide des sols de tourbières peut également avoir une incidence sur la production de gaz à effet de serre tels que le dioxyde de carbone, le méthane et l'oxyde nitreux.
Permafrost thaw may increase drainage of peatlands to creeks and rivers. Water from thawing peatlands can bring with it colored organic matter, nutrients, or mercury. These water quality aspects influences downstream aquatic habitats, the levels of toxins in fish, and also the suitability of water for consumption.
La plus grande partie de la recherche dans ce projet a été réalisée dans le bassin versant de Smith Creek, juste au sud de Wrigley. Nous avons mené plusieurs études dans les tourbières du bassin versant et nous avons surveillé le débit et la qualité de l'eau du réseau Smith Creek lui-même. Les recherches menées à Smith Creek s'inscrivent également dans le cadre d'études en cours qui portent sur des sites dans la région de Nuvik, près de Fort Simpson et dans le nord d'Alberta. Nous avons pour l'objectif à la fois de comprendre les impacts globaux liés au dégel du pergélisol en ce qui concerne les fonctions du paysage et les gaz à effet de serre, et aussi de répondre aux préoccupations des communautés quant aux impacts du changement climatique.
Hello, my name is Mike Lowe. I'm the coordinator for the Dehcho AROM program. It's run through the Dehcho First Nation, and it's a research and monitoring program for aquatic resources. So a few years ago, we had the pleasure of being introduced to David and his team at the University of Alberta. Summer field technicians were hired to collect samples from Jeemery River, Kakiza River, Trout River, Scotty Creek, and Smith Creek, which is right in the Wrigley traditional area of Pidzeki First Nation. Water is important to the whole Dehcho region. The word Dehcho refers to the Mackenzie River, which is the lifeblood of the area, and it provides transportation and food sources for the entire region.
Hello, my name is Jocelyn Skeard, and I am a member and resident of Pidzeki First Nation here in Wrigley Northwest Territories. Wrigley is a very small, remote Dene traditional community in the Dehcho region, and one of the project sites is located just outside of the community at Smith Creek. I've been very familiar with the project for a couple of years now, and just this past fall, I'm very excited to be a part of the team. What does water mean to me? Water is sacred and holds a very high role in our Dene culture. The importance of understanding and protecting it is of the highest concern. It shapes all of our Dene traditional values and activities. It sustains us in many ways, and I'm very grateful to be a part of the science behind it all.
Je m'appelle Gabrielle. Je suis professeur de recherche à l'Université de Montréal et de l'Université de Wilfrid-Laurier. Puis, mon travail m'amène principalement à étudier les gaz à effet de serre ou l'échange de gaz à effet de serre dans les territoires du Nord-Ouest. Mais mon travail m'amène aussi à travailler sur une multitude de projets en collaboration avec d'autres chercheurs qui passent de la physiologie des plantes à l'hydrologie de la marche. La composante terrain de mon travail est axée sur la conception, l'installation et la maintenance d'expériences qui mesurent les flux de gaz à effet de serre à différentes échelles spatiales. C'est important parce que ça nous permet de mieux comprendre les processus qui déplacent les gaz à effet de serre de la surface terrestre vers l'atmosphère et vice-versa. Je m'occupe ensuite de la préparation de l'analyse d'une multitude de données environnementales provenant de toutes nos stations afin qu'elles soient utilisables par notre groupe ou par d'autres collaborateurs à travers le monde. L'une des techniques qu'on utilise pour mesurer les flux de gaz à effet de serre à l'échelle du paysage s'appelle la covariance des turbulences. Ça consiste essentiellement à mesurer instantanément le mouvement cyclique de l'air à différentes fréquences, donc les turbulences, et ensuite de la concentration de gaz qui nous intéresse. Dans notre cas, c'est le dioxyde de carbone, le méthane et la vapeur d'eau qui sont des gaz à effet de serre. Cette technique permet de mesurer directement les flux à l'échelle du paysage, ce qui donne une image générale du comportement de l'ensemble des écosystèmes qui nous intéressent. Pour étudier les échanges gazeux à plus petite échelle, par exemple pour un type de plante ou une couverture végétale, on utilise un système de chambre à flux automatisé. Ça crée essentiellement une petite serre dans laquelle on peut mesurer des échanges gazeux avec un analyseur très précis.
I'm Tania Pigé. I'm a PhD student at the Université de Montréal, and my part of the puzzle is to better understand plant-water relationships in this area. So we've talked a little bit about how permafrost thaw at Smith Creek can change the amount of water in the ground. And this change in soil water availability can have big impacts on local forests. Trees act like really big straws, so they suck up water from the ground, use it for a number of different things, and then release it into the air. At Smith Creek, most of the trees have really shallow roots, so if there isn't much water at the soil surface, trees can become thirsty and are unable to grow. And these thirsty trees, or these water-deprived trees, also aren't able to release much water back into the atmosphere, so the whole flow of water is decreased. Similar things can actually happen when there's too much water at the soil surface too. For example, when wetlands are expanding into forested areas, the ground can flood, and this drowns any trees in the area. A drowning tree behaves very similar to a thirsty tree in that it's unhealthy, it can't really grow, and it doesn't push much water into the atmosphere. So my work is really focused on measuring the amount of water that's moving through these trees to get a picture of forest health and also water flow. So far, our work near Wrigley has shown that black spruce trees are stressed to the point of growth limitation, meaning that most black spruce in this area fail to obtain this fully hydrated status for close to 90% of the summer, meaning that they have just 2 to 10 days where they actually have enough water inside them to promote any growth. But the cool thing is that this species is really able to survive despite this low water availability. So it has really cool drought persistent strategies that allows them to still survive on this landscape.
I'm Christopher, a PhD student at the University of Alberta. I study and measure something that you cannot see: greenhouse gases. Greenhouse gases like methane and nitrous oxide are naturally produced by all ecosystems, controlled by biogeochemical factors like soil temperatures, nutrient availability, soil moisture, and water table depth. increased atmospheric concentrations of greenhouse gases have actually led to the current warming, which is particularly pronounced in northern ecosystems. Boreal peatlands have acted as greenhouse gas sinks for millennia. We can even determine the exact amount of carbon that has accumulated over time in the frozen peat core samples that we took at Smith Creek. But with ongoing warming, the ecosystems might lose the ability to act as a carbon sink in future. When I first walked out to the sites around Smith Creek, our wildlife manager Charlie from the Petsi Key First Nation community told me about the dramatic changes in the landscape that they have been observing over recent years. As it's getting warmer, the ground ice starts to rapidly thaw and ice turns into water. The ground collapses, and these so-called permafrost wetlands have very different soil characteristics, in particular higher soil temperatures and way higher soil moisture levels. And this changes the greenhouse gas production and consumption in the soil. We measure the soil gas concentrations at certain depths in the ground, and then we compare these from the forested areas against those from the permafrost bog areas. For example, under wet permafrost conditions, there is more methane produced, which is then released to the atmosphere, contributing to further warming. However, my research shows that the opposite is the case for another greenhouse gas, nitrous oxide, which is then actually good news for all of us.
I'm Lauren, a PhD student at the University of Alberta, and I'm investigating how the changing landscape of permafrost peatlands influences downstream water quality. As dry, treed peatlands thaw and form wetlands and lakes that have a greater ability to convey water, materials stored in permafrost may move across the landscape and into streams and rivers. We're particularly interested in the neurotoxin methylmercury. Some studies have shown that thaw wetlands are potential hotspots for the production of methylmercury by microorganisms. I've partnered with the Dehcho AROM program to monitor streams in the region, to record a baseline for current water chemistry, and to determine seasonal patterns of methylmercury concentrations. Smith Creek is a site that we've sampled intensively, and within the area that contributes water to the stream, I'm very interested in determining how the unique landscape of thaw wetlands, intact permafrost, and the Franklin Mountains influences water quality. Preliminary results have shown that peatlands are sources of methylmercury at landscape scale, but concentrations are well below levels that threaten aquatic health within streams. In continued work, I'm analyzing what controls the production of methylmercury in thaw wetlands within the Smith Creek watershed.
I'm Boku, a PhD student at the University of Montreal. My research is simulating border forest in ecosystem models. I focus on the carbon dioxide, water, and energy fluxes. The Canadian land surface scheme, including biochemical cycles, is the model I'm using. It's a model developed by the Environment and Climate Change Canada as a key component of the Canadian Earth System model. Most of my work is performed on the Compute Canada using the high-performance computing resource. At Smith Creek, I pay attention mainly to the adequate observations. They produce essential data for the modeling, and my simulation have provided a very important understanding of the model performance. I have also used the Smith Creek data to build a model dataset. The dataset will help validate classic and also other ecosystem models across the boreal forest of North America. In classic, I have used it to turn model parameters, and this work greatly improved the model performance. Further work is ongoing. I will continue to use the important data at Smith Creek to improve models, especially for better prediction in the future under climate change and permafrost thaw.
Throughout this project, we have learned both from our observations and from our Dehcho collaborators. This has led us to ask new questions and make new connections.
Nous avons contacté plusieurs partenaires de milieux académiques d'autres universités au Canada, au Royaume-Uni, en Allemagne et aux États-Unis. Ces derniers ont partagé leur expertise avec nous et ont pu mettre à profit l'infrastructure que nous avons établie sur le site de Smith Creek.
We now have funding to continue our research in the Dehcho region. Listening to our community partners, we're looking to put emphasis on two areas in particular. Firstly, we're looking to continue studying the impacts of climate change on water quality. And over the next couple of years, graduate students from University of Alberta will work with the Dehcho program to study mercury in creeks and rivers across the whole Dehcho region. And secondly, we're looking at improving the research capacity of the local communities within the Dehcho region.
En outre, nous avons reçu des fonds du Centre de compétences futures en vue de développer les capacités locales et de faire participer les membres de la communauté au suivi des changements climatiques dans la région du Dehcho et ailleurs dans le territoire du Nord-Ouest.
Hi everyone, my name is Emma Riley and I'm a research coordinator with University of Montreal. So one of my main duties as a research coordinator is to build connections with locals and community members that are interested in the FSC funded project, Climate Change Monitoring in Northwest Territories. So this project aims to provide job skills and training in environmental monitoring to locals using in-person and virtual learning resources. So I'm based out of Yellowknife, Northwest Territories, which really helps me to connect with people that are living in the territory because I can meet people face to face, at least during normal circumstances. I find it much easier to build these relationships while living in the territory because I tend to understand and relate to northern realities better, such as broken or sparse internet connections, or just the time it takes to get things done when it's really, really cold. So building relationships with locals is integral to understanding climate change, as people have been living and experiencing the realities of climate change in the North for decades. We have much to learn from locals, and our continued and improved collaboration with Indigenous communities is really important to the integrity and accuracy of the research that is done in the North. So our project is relatively new. We have really big goals. In the near future, I hope to see more of our field investigations being led by locals and community members as we grow closer to co-creating the research that is done across the Northwest Territories.